Okay. Right. Good afternoon. What about my audio, online students? It's fine, eh? Okay. Right. Okay, 3:32. Since it seems students are still joining in, right? I'll wait for another 2 minutes and we'll start. Huh? Let's wait for 2 minutes and start. All right. Okay. Good afternoon again. We'll start. Right. So last week we have finished simple harmonic motion. Right. We started oscillations and waves back in like 3-4 weeks back, and then last week we finished simple harmonic motion, and today we are going to start the next part of the lesson, because our unit was oscillations and waves, and the oscillations part was all about the simple harmonic motion oscillations. And today we are going to move on to the next section of the lesson, that is waves, that is all about waves, right? So this is the first day of waves that you are going to learn, right? And for another like 3 days you'll be entirely with the waves and wave phenomena. So basically in this part what we are going to learn is, now I know you know partially for some extent about waves from O level parts as well, right? I know you have like small things about waves now in O levels as well, right? But here in A levels what we are mainly focusing is wave phenomena, and they are like deep applications in the sense advanced applications, and you will be learning all wave phenomena in an advanced manner, and we'll be going into the deep down theories, and you are going to learn everything about waves here without having any like missing parts. You will be learning everything here. So that's what we do here in waves in A levels, right? So unlike O levels, in O levels it's like a touch and go, and you are doing several things here and there, but it is not the, what we say, the complete thing. That is not the complete thing. That is not the entire thing, right? So therefore, yes, in waves in advanced level here, aerial physics, we'll be learning everything, and yeah, after the lesson, for sure you will get to know about anything and everything about waves and wave phenomena, and all parts are followed with calculations, right? So therefore, not just theory parts. Now in the first part, there is a little bit towards theories, and then we are moving on to the calculation types as well. So in waves, all types of questions are coming. When it comes to questions also, both calculations, statements, arguments, graphs, every type of questions are also coming, right? So therefore, tend to the lesson from the beginning, from scratch, because you will be learning everything from scratch. Now sometimes in these first parts, you will see some of the parts that you already know are also discussed here in A levels, because since we need to take the start, I'll be starting from zero, I'll be starting from scratch. So therefore, sometimes there will be some basic things, basic facts that you already know about waves. But don't mind, but don't mind, because now having all basics firm, then we'll be moving on to other advanced lessons step by step, right? So therefore, please attend to the lesson, be vigilant in the class, and attend to the lesson from the day one onwards, from today onwards, day one onwards. Okay, right. So take down the heading as waves. We'll go to the thing, waves. Take down the heading as waves. Waves. Okay. I have a small question. Listen, I have a small question. That is, tell me what a wave is in your thoughts, in your words. What is a wave in your words? What is a wave in your words? Anyone? The ones who are on the online students, ones who are on Zoom, you can put your answers to Zoom chat as usual. And the ones who are on YouTube, you also can put your answers to YouTube live chat, so I can see. What do you say? Anyone? Any idea about what a wave is in your words? I don't need any definitions, right? I don't need definitions. I don't need proper introductions. Just tell me what a wave is in your words. What is waves in your words? Anyone? Anyone? Use your O-level knowledge. Recall what you have learned in O-levels. Right? So moving to A-levels doesn't mean that you have to forget everything about O-levels. Right? Yeah, use your knowledge. And one another important announcement, listen. One announcement is, yeah, I got few inquiries about the registration in the website. Yeah, it's undergoing a little bit of updates, few updates these days, right? For the students who asked, I told you the website is working, but still there are a few updates ongoing, right? So therefore, it'll be fixed during next like 2-3 days, within next 2-3 days. So after that, you can go there and register. And if you have made the payment to a different institute, what you can do is you can upload the slip that is issued by the institute there on my website, and you can complete the registration, right? So I think that is already informed to you from the institute as well, right? So I just told you because I got few inquiries from students whether it's working or not. Yeah, it's working, but yet some updates are ongoing, right? So therefore, I'll again circulate a message among you all once all updates are done, right? Okay, now back to the topic. Tell me. No one? Okay, listen. Wave is simply a transfer of energy. Listen. Wave is simply a transfer of energy, right? Wave එකකින් අරන් යන energy එකක්. Energy එකක් point to point අරන් යන තමයි wave එකක් use කරන්නේ. That can be any type of a wave, like a sound wave, optical waves, or transfers, electromagnetic in the sense there are like more waves in the spectrum. In the spectrum, you know, there are X-rays, cosmic, gamma, X, ultraviolet, visible, radio, TV, micro, satellite. So there are more forms of waves. But what any wave does is, it is carrying energy. It is transferring energy, carrying energy, right? So therefore, wave is a form of transferring energy as oscillations or as vibrations, right? Using vibrations or using oscillations, if energy is transferred, that is called a wave, right? So we will see how these vibrations occur, how these oscillations occur, and what are the forms we have, what are the types of waves we have, the categories of waves. So there are more things to be discussed today, because today I'll be laying all foundation for the lesson waves, right? For the wave phenomena, we are doing all foundation before moving on to questions, calculations, right? Okay, so as the first point, write down with an asterisk mark. You better put an asterisk mark and write down. First point: a wave is a flow of transfer of energy, right? Like this. Flow of transfer of energy. In the form of oscillation. In the form of oscillation. Within brackets, vibration. In the form of oscillation, and within brackets, vibration. In the form of oscillation, within brackets, vibration. Through a certain medium. Okay, look at here. Look at the board. Now, with that introduction, I explained using three key terms actually. Look at here. One is there is a transfer of energy, right? First thing is wave is the transfer of energy, right? And it should be using oscillations or vibrations. They are the keywords. And there should be a medium. But about the medium, there is one wave type which doesn't require a medium. Doesn't require in the sense having a medium or not, electromagnetic waves can transfer, right? That's the only type of wave that can be transferred without a medium. So therefore, even though I say about the medium in the introduction, only for electromagnetic waves, medium is not mandatory. Yeah. So which means having a medium or not, it will transfer anyway, right? Even though it's a vacuum, it transfers, right? Now from your introduction, highlight or underline these three. Transfer of energy, oscillation or vibration, and medium, right? Three keywords. So when you keep this in mind also, when you going through this again also. Try to keep it in mind using these three keywords. Transfer of energy, right? Very easy. Only three things. Transfer of energy, oscillation or vibration through a medium. Through a medium, right? So highlight these three. Highlight or underline these three. Highlight or underline these three. Right. As the next heading, write down classification of waves. Next heading, classification of waves. Classification of waves. Yes, listen. About the mechanics practical seminar tomorrow. Yeah, it will be happening tomorrow at 8:30, right? At 8:30 a.m. That is the first practical seminar we are conducting, and that's a mechanics practical seminar we are going to have, right? Mechanics. So there are all the practical sessions, all the experiments that we have under mechanics will be discussed, right? So everything about the practical sessions in mechanics will be discussed, right? So, so therefore, it is very important. Don't miss the class. And for boys, I got some inquiries whether I'm giving a time to pray during the afternoon or something like that. Yeah, I'll be giving you a time, giving you a break around 12:30 to 1. 12:30 to 1 or 12:30 to 1:15. I'll see with the plan tomorrow, right? So anyway, I'll be giving you a break to pray and come. So therefore, don't worry. So you can join the session at 8:30, and we'll be continuing it straight away until, let's say, 12:30, and then I'll be giving you a small break. And during that break, if you are a Muslim student, you can go pray and come, and you can have your lunch. You can have a meal if you are having something, and you can come back to the class again, right? The planned time to finish the class, finish the seminar is by 2:30. So if I manage to complete everything that I'm planning to complete before 2:30, let's see whether we can stop before 2:30. That depends on the speed that you are attending for the things here, right? So if you do the things quickly, right, then if I finish the planned parts before 2:30, let's say by 2 we have finished, then by 2 I'll end the session, right? So that is how it goes. So therefore, yeah, please join at 8:30. If you are in and around Colombo, you can come here to the Machma Institute physically, and if you are an online student, you can join online, right? Whether you are a regular student or not, all of you will get a tute, and in that tute, I have included everything in the sense all the facts, details, and the notes about each of the practical we are going to discuss tomorrow, right? So therefore, share the message, pass the message among your friends and colleagues. So if they are joining, they can join either physical or online, right? For all updates, you can either contact me personally or the hotline number here at Machma College, or you, through our channels and groups also, you can get all updates, right? Sir, which one draw certain medium? Sorry, I didn't get your question. So will you deliver the truth? Yeah, for online students, you are asking for the theory class, ne? Regular class. For tomorrow's seminar, I'll be giving the soft copy of the tube for online students, and for the physical students, they can get the hard copy. Yes, if you are asking about the theory class, yeah, for the theory class students, tubes are delivered, right? So tomorrow we are going to have a free seminar, no? And we don't have addresses of all the students who are going to join to the class. So therefore, for the online students, I will send you the soft copy. If needed, you can get a hard copy and refer it later, right? All right. Yeah. Then classification of waves. Listen, look at the board. So basically, waves are classified into two categories. Basically, waves are classified into two categories. First category is called electromagnetic waves. Right? First category is called electromagnetic waves. Electromagnetic waves. And the next category, next classification is called mechanical waves. Mechanical waves. Mechanical waves. Electromagnetic waves are also called non-mechanical waves, right? Mechanical and non-mechanical. So electromagnetic waves are also called non-mechanical waves. Non-mechanical waves. Non-mechanical waves, right? So basic categorization, listen, basic categorization of waves is as this, as electromagnetic waves and mechanical waves. Electromagnetic waves are also called non-mechanical waves, right? The popular name is electromagnetic waves, right? I think you might have also asked about the electromagnetic waves, not the non-mechanical, not as non-mechanical, but that is also called non-mechanical. And when it comes to mechanical waves, there are other two types of waves with respect to the way they transfer. Way they transfer in the sense with respect to the pattern of vibrations they have in the wave. Again, mechanical waves are divided into two or classified into two. They are called, I know you know this classification. We are just recalling the things to get the start, right? We are recalling the things to get the start. Transverse waves, transverse, and longitudinal waves. Transverse waves and longitudinal waves, right? So this classification is, listen, classification of waves as electromagnetic or mechanical is based on its requirement of medium to transfer. If it needs a medium, if a medium is mandatory, if a medium is compulsory to transfer the wave, to propagate the wave, such waves are called mechanical waves. If a medium is not mandatory, not compulsory, such waves are called electromagnetic waves, right? And this categorization here as transverse and longitudinal is based on the vibrations of the wave. If the vibration is perpendicular to the propagation direction, they are called transverse waves. If the vibration is parallel to the direction of propagation, they are called longitudinal waves, right? So here the thing is, all electromagnetic waves are transverse. All the electromagnetic waves are transverse. So that's why we can't categorize this into two as transverse and longitudinal again, because all electromagnetic waves are transverse, right? That's the idea. Otherwise, now when I write the classification like this, when I classify like this, so don't think that only mechanical waves can be categorized as transverse and longitudinal, and transverse is a subcategory of mechanical. No, that is not the case. Transverse is not a subcategory of mechanical. All electromagnetic waves are also transverse. All electromagnetic waves are also transverse, like this. So therefore, don't misunderstand. Sometimes from O levels, you might have some kind of misunderstandings or messing up things with these categorizations. The reason is that this categorization is based on two facts. First one is based on the medium, requirement of a medium, and this categorization, this classification is based on the vibrations, type of vibrations. Right? Is it clear? Clear there? Quickly. Clear there, students? Yes, okay. All right. Now take this down. Take this down. This part. Starting from here, put the heading as classification of waves. Put the heading as classification of waves and take this down. Take it down. Yeah, if you have any questions, doubts, and if you need any clarifications with the things that you have learned in O levels, you can ask, because yeah, I know there are some things in O levels. There is some way that thing can be expressed because of the restrictions you have. Restrictions in the sense because of the limitations in the particular section or the lesson that you have, there are some things that are skipped in O levels, right? හැම එකම කියන්න බෑ from A to Z in O levels. ඕනෙම ටික විතරක් කියනවා, like only the most important facts are there in O levels, but sometimes you don't see those connections because of that, right? Now you can connect all dots after you learn waves in A levels here, right? So therefore, if you need to know about anything, right? Anything about anything, feel free to ask anything. Feel free to ask anything. So mechanical waves are divided based on what? Divided based on type of vibration. Type of vibration. Type of vibration. So don't worry, we will be coming to those parts in the next part. I mean, we'll be explaining about each of these classifications one by one in the next part. We are going to explain. I'm just showing you the classification here, and then I'm going to take electromagnetic waves separately and transverse longitudinal separately, and we are going to see the features, attributes about these wave classifications, right? So therefore, don't worry about that. That is coming up. That is coming up. Haya, did you ask about the theory class or about the mechanical seminar, mechanics practical seminar tomorrow? About the tubes? If you didn't get the expected answer about that, please ask the question again. So I guess you have asked about the theory class. Are you asking about practical seminar? No. For the practical seminar, it's a free seminar we are going to conduct now, right? So therefore, anyone can join. Anyone can join. So from my side, what I can do is I'll give all the online students the soft copy of the tute, and all the physical students the hard copy of the tute, right? So when you come to the institute, you can get the hard copy. So if you are living in and around Colombo, I'm encouraging you to come to the physical class, right? Then you can get the tute and finish everything there. And if you are an online student, right, now in this class also, I know there are students from Kandy, Bambalapitiya, Gold. There are students from different places. Varakapola, yeah, K Gold, yeah. So therefore, for online students, I'll provide the soft copy, right? During the session, you can manage with the soft copy, and if you feel like you need to get a hard copy, what you can do is you can take a print out of that PDF. I'll be sending you a PDF now, that PDF that I'm sending, and you can keep it with you for your reference, right? Is that clear? Soft copy you will send on the channel. Yeah, it will be available tomorrow morning in my channel, in WhatsApp and Telegram. So if you are in either of them, you will get it. So as mentioned in the flyer that I shared, please join to one of those channels or both, and tute and the study materials for free sessions, free seminars will be shared on my channels. Right? All right. Finished, right? Okay, now we'll see what these classifications are one by one. First, write down the heading as electromagnetic waves. First heading, electromagnetic waves. First heading, electromagnetic waves. First heading, electromagnetic waves. Electromagnetic waves. Right. So as I told you before, as I explained before, for electromagnetic waves, having a medium is not compulsory. Having a medium is not compulsory. So which means that doesn't matter whether if there's a medium or not. Right? That's the idea. That's the idea. As an example, when visible light is coming from sun to earth, right? When visible light is coming from sun to earth, there are air packets in the sense vacuum mediums in between, but still visible light comes. That is because visible light is one of the electromagnetic waves. Otherwise, if visible light was not an electromagnetic wave, visible light won't come through vacuum mediums, right? So at least an air medium is required. But the specialty about electromagnetic waves is they don't require a medium to transfer. They don't require in the sense that is not compulsory. That's the idea. මේ සමහර අය හිතාගෙන ඉන්නවා medium එකක් නැතුව යනවා කියලා. එහෙම නෙමෙයි. medium එකක් essential නැහැ. medium is not essential. That's the idea. දැන් medium එකක් තිබ්බොත් ඒ medium එක යනවා. Otherwise medium is not essential. If it has a medium, then it propagates through the medium. But if not also, that doesn't matter because medium is not compulsory. That's the idea. Right. Electromagnetic waves. Under that, first point, write down in point form. First point, write down in point form. First point, a medium is not essential to, a medium is not essential to, a medium is not essential to propagate. A medium is not essential to propagate electromagnetic waves. Medium is not essential to propagate electromagnetic waves. Medium is not essential to propagate electromagnetic waves. Right. Next point. Second point. All types of electromagnetic waves. Second point. Second point. All types slash forms. All types slash forms, like this. All types slash forms of electromagnetic waves are in electromagnetic spectrum. are in electromagnetic spectrum. Are in electromagnetic spectrum. Are in electromagnetic spectrum. I'll write it here. Electromagnetic spectrum. Electromagnetic spectrum. Right. Okay. I know you have come across electromagnetic spectrum in O levels. Right. So tell me now, before I write the spectrum, since this is something you know, and I'm for sure I know you know about electromagnetic spectrum. Sometimes you might not remember the series in order, but if you can remember the series in order, that's very good. So if not, also I know you know the forms of electromagnetic waves which are in electromagnetic spectrum, right? So tell me, what are the electromagnetic waves you know? All the waves are in electromagnetic spectrum. When I explained before also, for the explanation, I just said these electromagnetic waves, electromagnetic spectrum waves in my first explanation also. Yeah, tell me, what are the types of electromagnetic waves you know? X-rays, visible rays, gamma, X, ultraviolet, infrared, visible, good. Micro, gamma, okay. UV, micro, radio. Right. Okay, listen. Now, since there are quite a few forms of electromagnetic waves are in electromagnetic spectrum, electromagnetic spectrum is defined in an order, right? So that is defined in the ascending order of frequencies or the descending order of wavelengths, right? From either of the sides, you can keep that in mind, right? But definitely, you have to know, you have to keep this in mind, you have to know electromagnetic spectrum, because when it comes to questions, you have to compare and contrast between these forms and even among the 7 colors in visible light also. So therefore, we'll be writing it in the order, in the correct order. Then I don't mind whether you keep in mind with from the top end or the bottom end. That doesn't matter. But somehow you should be able to keep that in mind, right? You should be able to keep that in mind. Okay, look at the board. I'm going to write the electromagnetic spectrum. Look at the board. I'll be writing here. See, first one, cosmic, gamma, X. Now, if there are rays that you don't know their terms, names, right? If I didn't mention the name here, usually I'll be mentioning the symbol, right? Now, as an example, for gamma symbol. Now, if you don't know about gamma ray, what you can do is when you take this down, you can write that in words if you don't know that in words, right? Okay, cosmic, gamma, X, ultraviolet, UV, visible, cosmic, gamma, X, UV, visible, IR, micro, satellite, TV, and radio, right? This is called the electromagnetic spectrum. And here what we are mentioning is the main forms and the main types of electromagnetic waves we have. Main types. So other than that, there are some other not main subtypes in between these ones as well. I'll explain what those are, but for A levels, for A level physics, you don't need to know about those subparts. I'll just explain what those subcategories are, subtypes are. But for A levels, we don't know, and this is a standard one. Huh? This is a standard electromagnetic spectrum. Right? Okay. Sometimes you might not seen cosmic waves in O levels. Cosmic කියන එක අහලා තියෙනවද? Anyone? Anyone heard about cosmic waves or cosmic rays? Is there anyone? Oh, you didn't have that in O levels, sir? No, didn't have. Right. Yeah. So in O levels, usually about cosmic waves, you are not taught. I think in O levels, the spectrum starts from gamma, right? Gamma වලින් නේද පටන් ගන්නේ O levels වල? එහෙමද? gamma නේ? Yes. So that's why I told you now in O levels there are some things they are missed in O level science, right? So now when you learn everything from the beginning, connect all those things, connect all the dots and complete this picture, right? So the wave with highest frequency is actually cosmic. That is not gamma. Gamma is the second highest. Highest frequency is cosmic, right? Cosmic. Now here this is written like this. This is written like this. This is written in the ascending order in the way of increasing frequencies. Ascending order of frequencies, which means highest frequency is here and the lowest frequency is here, right? And always frequency and lambda are two inverse properties. Higher the frequency, lower the lambda, because V equals F lambda now. When V remains same, everybody of you know V equals F lambda. When V remains constant, when F increases, lambda decreases, right? So therefore always F and lambda are two inverse physical quantities. When F increases toward this side, lambda decreases towards the same side, right? About visible light also, you have to know these colors inside visible light, right? You have to know these colors inside visible light. Anyone has any idea about the color with the maximum frequency, highest frequency? Anyone from your O levels knowledge? What's the color with the highest frequency? Violet, yeah. Lowest frequency? Orange, yellow, no. You know about the highest frequency, but not the lowest frequency. Yeah, it's red. Yes, it's red, right? Therefore, visible light is categorized into these 7 colors like this. See, highest frequency is with violet. Violet. See, it goes like this. It goes like this. Violet, indigo, blue, green, yellow, orange, red. Right? So usually you can keep this in mind as Vibgio. Right? Sometimes you have heard this in O levels also. Like this, Vibgio. Vibgio. Right? Now towards this side, it is like this. Towards this side, towards this direction, frequency increases. Towards this direction, frequency increases. Right? Then towards the opposite direction, lambda increases. Towards the opposite direction, lambda increases. Right? Now, if this series is known, which means you should be able to compare and contrast between frequencies, wavelengths of each of the waveforms in electromagnetic spectrum, right? So you should be able to compare. That's the learning outcome behind this, right? And when it comes to questions, you will be questioned about the colors, some things about frequencies, deviations, wavelengths, speeds of colors as well, right? So about speeds and refractive indices, speeds, deviations, those things are coming up. Now here in the spectrum, the first learning is this about frequencies and lambda values. Lambda in the sense wavelengths, right? Okay, first take this down. And other than that, I told you the main types are mentioned here, only the main types. Other than that, inside this series, inside the spectrum, we have rays like radar. That is not a main type, so that's why we don't mention that here. Radar is in between satellite and micro. Radar signals, you know, right? So therefore, we don't mention radar, but that is also a type of an electromagnetic wave that is in between micro and satellite. And when it comes to what else? Wi-Fi signals, Wi-Fi, Bluetooth, they are also these categories, but they are not the main categories. So within the infrared range, we have Bluetooth, right? So likewise, Wi-Fi is in this range. So likewise, those rays which we are using in day-to-day life, those waves which we are using in day-to-day life, that is also inside this spectrum. But we don't mention them since they are not in the main types, right? Make a type subcategory. Now, as an example, IR is or Bluetooth is inside IR, right? Bluetooth is inside IR. Likewise, that's why we don't mention Bluetooth separately. Got it? Is it clear, students? Is it clear? Need a response? Is it clear? Quickly. So if it's clear, say it's clear. If not, if I need to explain it again, if you need me to explain it again, that's also fine. Just tell me you didn't get and explain again. So can you repeat the last thing you said about Bluetooth? Yeah, about Bluetooth, what I said was, listen, about Bluetooth, what I said was, Bluetooth is also an electromagnetic wave, but we don't mention it in this main categorization, right? In the main spectrum, we don't mention it. They are the subtypes, and Bluetooth is a subtype inside infrared range, right? So likewise, that is not just these ones in day-to-day life. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, only 10. Only 10. But around like 50, 60, or maybe more than that, types of electromagnetic waves are there. They are inside these main categories. Only 10 main categories are there. Bluetooth is not a main category. Right? Is it clear? Okay. Take it down. Take it down. Electromagnetic spectrum. Take it down. Yeah, the idea of these colors are, which means visible light consists of 7 different colors. That's the idea. Yeah. Visible light consists of 7 different colors. And when all 7 colors are together, we will see it as transparent. We don't see any color. That's the beauty of that. When all 7 colors are together, that is transparent. Right? But if we check these colors through color dispersion, we will be discussing about color dispersion in the coming parts. through a lens or through a prism or any refractive medium, we will see all 7 different colors, right? That is because it consists of 7 different colors. But when all 7 colors are together, we don't see any color. That is totally transparent. That is why we see this visible light as transparent. We don't see any color there. Reason is that, right? Splitting into colors is called color dispersion. Splitting into 7 different colors, splitting is called the color dispersion. If needed, you can mention it here. Color dispersion. Color dispersion, right? Splitting visible light into 7 different colors is called color dispersion. Okay, any other questions? Okay, finish copying down, students. Finish copying down. Okay, any questions? Finished. Okay, right. Next heading. Next heading, features of electromagnetic waves. Features. Features of electromagnetic waves. Features of electromagnetic waves. Features of electromagnetic waves. Okay, so we'll discuss about the features one by one, and with each feature we'll be explaining, right? Okay, features of electromagnetic waves. First one. One feature you already know by now. Tell me, what are the features you already know? Now, in my explanations also, I explained about one feature before that you know. So other than that, if you know any other features also, tell me. I need to connect these things, connect the things with the things you already know from O levels. That's why I'm asking these questions. I'm keep asking the questions because I know up to some extent you are doing this in O levels, right? So therefore, I need to connect all your dots in O levels with the things you learn here in A levels. That's why I'm asking questions to check your level, your current level that you are. Yeah, any answers? Does not require medium, travels through vacuum. Medium, yeah. Yeah, about the medium I mentioned. That is correct. That's one of the features. Okay, then write it down as the first one. First feature. A medium is, write down, a medium is not compulsory. A medium is not compulsory. A medium is not compulsory. Slash not essential. a medium is not compulsory slash not essential, not compulsory slash not essential to propagate, to propagate. A medium is not compulsory slash not essential to propagate. Second one, travels with velocity of light, travels with velocity of light, travels with velocity of light in air or vacuum media, in air or vacuum media, travels with velocity of light in air or vacuum. In air or vacuum media. Right? Within brackets, you know velocity of light. Within brackets, velocity of light 3 times 10 to the power 8 ms minus 1. So you know about velocity of light even from more levels, and in units and dimensions also. When we find the value of a light year, right? We are discussing this value. You have come across this value 3 times 10 to the power 8 meters per second, right? So in all also you have, but in A levels, yes, we have in units and dimensions. Exactly when we determine the value of a light year. Okay, I hope you can remember. Next one, write them down one by one. Right, next one. Cannot be deviated. Cannot be deviated. Third one. Cannot be deviated. Cannot be deviated by electromagnetic fields. Cannot be deviated by electromagnetic fields. Cannot be deviated by electromagnetic fields. Since net charge is zero. 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 Okay, that is like this. Now, if you are doing chemistry, you know you can deviate or deflect alpha and beta using a magnetic field. No? Alpha rays or alpha particles and beta particles can be deflected, can be deviated using magnetic fields. But gamma cannot be deviated because it doesn't have a charge. Right? Gamma is one of the electromagnetic waves. So likewise, as gamma, for all electromagnetic waves, there is no charge. For all electromagnetic waves, they have no charge. Since they don't have a charge, they cannot be deviated. Right? They cannot be deviated. Right? These mobile network signals we get also, they are also electromagnetic. Right? Now we are getting wireless data to our mobiles, no? Mobile networks in the sense wireless networks. I'm not talking about the Wi-Fi. The connection from that tower to tower, you know, there's a main tower in somewhere in the town, and there's a particular radius that it can cover. Right, now from tower to the mobile phone, that also comes as that mobile data, or say mobile data network, that signal comes as an electromagnetic wave. They are also electromagnetic. right? If that is wired, that is different. Wired in the sense, if that's a LAN connection, that is different. LAN means that's through wires, right? But when the signal is coming from tower to the mobile phone, that's an electromagnetic wave. And about that, there are some rumors as well. Rumors in the sense, have you heard about someone like maybe our parents or sometimes grandmas, grandpas? They say that don't take calls during thundering hours, thundering times, lightning times. කියලා එහෙම කියනව නේද? වැස්ස වෙලාවට නැත්නම් අකුණු ගහන වෙලාවට, ගොරවන වෙලාවට මේ ෆෝන් කෝල්ස් ගන්න එපා. don't make phone calls කියලා එහෙම අහලා තියෙනවද? Deviated means changing the path. Deviated means changing path or changing direction. So haven't you heard that some of the people say don't make phone calls during thundering? කියලා එහෙම අහලා නැද්ද? anyone? ලංකාවේ නෙමෙයි ඉන්නේ. Yeah, you should have heard. Yeah, have heard. Yes, definitely you should have heard. I mean, in Sri Lankan context, that's a very popular saying. It's a very popular saying that they say don't make phone calls in thundering hours. But the thing is this. Since electromagnetic waves don't have any charge, they don't have any capability of attracting lightning signals or lightning thundering or something like that. ඕක charge එකක් තිබ්බොත් නේ attract වෙන්නේ. දන්නවනේ OLEDs වලත් පොඩි පොඩි දේවල් තියෙනවා, and you will see the big picture in electric fields, right? So if there is a potential difference having two different charges only, that lightning will be attracted, right? That will be attracted to ground or somewhere. Now, if you make a phone call, signal comes as an electromagnetic wave. Electromagnetic waves are neutral in the sense they don't have any charge, so therefore they don't have any power or any capability of attracting lightning, right? So therefore that's a rumor in the sense that that's a what we call a false statement. That's a false statement. එහෙම එකක් නෑ. But there's a risk if you are making a phone call while your phone is charging, while your phone is on the charge. If there is plugged to your main circuit in the household home, there's a risk, right? එහෙම වුණොත් ඒක වෙන කේස් එකක්. ඒක වෙන්නේ අර phone signal එකේ නේ, phone in the sense not from the electromagnetic signal, right? current එකට connected නම් ඒක කරන්න දෙයක් නැහැ. That is not about the electromagnetic wave. But if your phone is not connected to the charger, if that is not connected to a closed loop, a circuit, right? If you are using your phone without connecting to any of electric currents, there is no risk of attracting lightning, right? That's the point. And there are cases, I have also seen the news and all that. News are getting viral, like when this person is on a call, he has got this lightning attack ඔය වගේ news යනවා. But once we dig deep down, most probably they have use it with the charger එකට ගහලා තිබ්බොත් නම් කෙලිම ඒ කියන්නේ එන voltage යන්නේ, voltage එක කෙලිම body එක through යනවා කියලා කියන්නේ අර burn වෙලාම යනවා. It will be burnt. Okay. ඔය ඉන්ටර්නෙට් එකේ තියෙන ෆොටෝස් පස්සේ වෙලාවක් ගහලා බලන්න. ඒ වගේ කේස් වුණාට පස්සේ ඒ කියන්නේ charger එකකට ගහන් ඉඳලා වගේ අකුණක් වැදුනොත් නම් burn වෙලාම යනවා. ආයි කවුද කියලාත් හොයන්න බෑ, මේ ඒ මනුස්සයා කවුද කියලාත් හොයන්න බැරි වෙන burn වෙනවා. Right? That is because of that connection to the main circuit, right? Main circuit eකට connect නොති කරයි. But if you haven't connected, there's no risk, right? So there's no logic, there's no risk. The reason is this: they are neutral. Electromagnetic waves are neutral, no charge, they are neutral. They are neutral, right? So you can make sure your phone or whatever the device is connected to the main circuit or not. If not, there's no risk of calling during lightning hours. That's why. Okay, next one. Next one. All electromagnetic waves are transverse waves. 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 There's a question. But sir, is it only for calls while charging? Is it okay if we use the phone while charging? No. Now we are using means that is also, now you are getting that incoming signal to your mobile device, right? Use කරත් ඔයාගේ main circuit එකට connected නම් කරන්න දෙයක් නැහැ. use කරත් වදිනනේ. call ගන්නවද ඒකෙන් ඔයා social media ආද ඉන්නේ නැත්තම් වෙන මොනවා හරි games play කරනවද එහෙම කියලා වැඩක් නැහැ. main grid එකෙන්නේ ඒක වෙන්නේ. ඒතර main circuit එකට එන එකක් වුණොත් අනිවාර්යයෙන්ම වදිනවා. right? I clearly said if your device is not connected to the main circuit in the sense අපි usually the phone එක connect කරන්නේ charge කරන්නනේ. So if there is not on charge, right? If there is not on charging, there's no risk. But if there is charging, doesn't matter whether you are making calls or browsing on social media or whatever it is, then the risk is there, right? I said that clearly. Next one. Next feature 5. All wave phenomena. 5. All wave phenomena. All wave phenomena. All wave phenomena. Listen. There are 5 wave phenomena. There are 5 wave phenomena that any wave can undergo, right? Now we are going to mention those names, and in this lesson what we are covering is about these phenomena with the calculations. That's the part that we are covering, right? So namely, these are the phenomena of a wave, right? There are 5. Keep them in mind. First one, reflection. About reflection, I know you have already heard, at least you have heard about reflection. First wave phenomenon is reflection. Second one is refraction. About refraction also you have heard, right? And after reflection and refraction, you don't have heard because they are not in O-level syllabus, right? The third one is called diffraction, right? So don't worry about the meaning of the phenomena, the function of the phenomena, because that's what we are learning in the coming parts, right? Just hear these names out and keep them in mind, right? Reflection, refraction, diffraction. 4, interference, and 5, polarization, right? 5, polarization. All right, දැන් මම මතක තියාගන්න. එතකොට ඉවරයි මේ වැඩේ. Reflection, refraction, diffraction, interference, polarization, right? Okay, so what I mentioned here was all wave phenomena such as, put a comma and write down one by one. Put a comma and write down one by one. All wave phenomena such as, put a comma and write down one by one. Reflection, Second one, refraction. Third one, diffraction. 4, interference. Interference. 5, polarization. 5, polarization. Right, such as reflection, refraction, diffraction, interference, polarization. Can be done. Can be done. Can be done. Right. So there are only 5 wave phenomena. Only 5. Right. These are the 5 wave phenomena. Right. When it comes to electromagnetic waves, all 5 can be done. And there are some wave categories they can't undergo, and some of these categories, some of these phenomena. Right. Okay. Next one. 6. 6. It consists of 6. It consists of 2 electric and magnetic fields. It consists of 2 electric and magnetic fields. It consists of 2 electric and magnetic fields perpendicular to each other. Right? Consists of 2 electric and magnetic fields perpendicular to each other. Perpendicular to each other. Right? Wait here, it's like this. It's like this. It's like this. Look at the board. This is one of the fields. This is one of the fields. One of the fields. And as perpendicular to this field, there's another field like this. Right? As perpendicular to this field. Can you see? So as it is perpendicular to this field, there's another field like this. 2 fields. One is electric and the other one is magnetic. So this is like, it's a magnetic field. And this one in blue is the electric field. Right? And wave propagates in between. Wave propagates in between. Now, this is the direction of propagation of wave. This is the direction of propagation. Right? So simply, direction of propagation of the wave is like this, and there is one field in the perpendicular direction that is electric, and the other one is magnetic. So both acts together, both work together when the wave is propagating. Right? So like this. Take it down. Take it down. Take it down. Yeah, you can forward your questions if you have anything. Is it clear? Ask your questions if you have anything to know. Okay, is it all clear up to this point? Take this down. Huh? If you are using different colors, you can use different colors. Use two different colors and take it down. Shall I show you an image of that? A graphic? Then it will be more clear. Give me 2 minutes. Clear than that graphic cap pen. Tell me. Is that clear enough, or do you need a graphic or an animation? Animation to see it properly quickly. So if not, we can move on if it's clear. Tell me quickly. Okay, give me 2 minutes.
Recording in progress.
Wait, I'll show you. Okay, can you see my screen? You can write. Can you see this? This is how it's propagating. Can you see this screen? Yes. This is how it's propagating. That is how it's propagating. Right? So that's why I told you there are two separate electric and magnetic fields. They are perpendicular to each other. Right? So both are in that wavy sinusoidal form. These two are the two fields, magnetic and electric. Okay, students, is it clear? Is it clear? Any more questions? Okay, now it's more clear. Eh? Yeah, good. All right. Okay, back to the topic. Right, back to the topic. Next point. What's the number question? Point 7, right? 7, eh? 7, 08, 7. Next one. Velocity of an electromagnetic wave. Write down. Velocity of an electromagnetic wave. Velocity of an electromagnetic wave is given by write down this equation. Velocity of an electromagnetic wave is given by velocity of an electromagnetic wave is given by velocity of an electromagnetic wave is given by V equals 1 over root mu naught epsilon naught. This is called mu naught, mu and mu naught. This symbol is called epsilon or epsilon. So that is called epsilon naught or epsilon naught. Right? Like this. This is called mu. These are Greek symbols. Huh? That is called mu. And this symbol is called epsilon. Right? Symbol level. That's not the definition of the notation. Notation is used for permeability and permittivity. Right? That we will see. This is a symbol. This is called the mu symbol. This is the epsilon. Right? So equation is V equals 1 over root mu naught epsilon naught. Okay. Introduce mu naught and epsilon naught. Introduce these two. Introduce mu naught and epsilon naught. Mu naught. Mu naught is permeability. 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 So don't worry about the word permeability now because that is actually coming from magnetic fields. We have a separate lesson as magnetic fields coming up. There you will see these things in a very in-depth manner, right? Just know for now, permeability determines number of magnetic field lines in a particular space, in a certain space, right? Number of magnetic field lines, or simply the strength of magnetic field in a certain electric field, permeability, right? And epsilon naught is called permittivity. 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 Permeability and permittivity. Permeability and permittivity. Permeability and permittivity. Right? And permittivity is about the same thing about electric field lines. So it determines number of electric field lines in a particular space, a certain space. So it determines the strength of electric field in a certain space. Right? Determines the strength of electric field in a certain space. Right. Next one. Next one. Any questions? After 6 points, can you repeat it? What's the point you are asking? The last point was this. Last point was this. Last point was this. Velocity of an electromagnetic wave is given by the equation and mention the equation. Right? Next. Electromagnetic waves transfer energy. Write down. Next point. Electromagnetic waves transfer energy. Next point. Electromagnetic waves transfer energy. Electromagnetic waves transfer energy as energy packets. Transfer energy as energy packets / quantum packets. Electromagnetic waves transfer energy as energy packets / quantum packets. See? Energy packets. Or it is also called quantum packets. Right? Take it down. Right? So they transfer energy as energy packets, quantum packets. Next point. Energy of an energy packet. Energy of an energy packet. Next point. Energy of an energy packet is given by energy of an energy packet is given by, mention the equation, E equals hf. Energy of an energy packet is given by E equals hf. Right? So sometimes you might have seen the same equation in chemistry as equals h nu. Right? Sometimes as equals h nu. But don't use nu here in physics. Right? Use f. Equals hf. Right? Introduce terms. H Planck's constant. H Planck's constant. F frequency of wave. Frequency of wave. Can you write the name under epsilon naught? You are asking about this permittivity. Is it this one? Permittivity. Is that what you asked? Permittivity. Can you write the word for H? Planck's constant. Planck's constant. Right. Now, from these features that we discussed, you have to keep them in mind. Right? Now, all 10 or 9 won't be asked. Right? But you will be asked to write down 3 features of electromagnetic waves, so 5 features of electromagnetic waves likewise. So therefore, you have to know these features. Right? Okay. Any questions up to this point? Tell me. Any questions up to this point? Now we have finish the discussion of features of electromagnetic waves. Features, just the features of electromagnetic waves. Any questions up to this point? Quickly. Tell me if there's anything before moving on. Oh, okay. Planck's constant, yeah, Planck's constant. E in red color. Sorry? Sorry, I didn't get your question. E in red color. What you are saying? E in red color. How many points are there in electromagnetic waves? Which means it is diffraction. First one. Di. Di. Di, first one. Is the last point also a feature? Yeah. Because energy can be written as E equals HF. That's a feature. Ah, you are asking number of points I gave you. That I didn't count. How many points? I think it's 9 or 10. I didn't count. I just gave you the features. I didn't count the points. I think it's 9 or 10. Was it 9? Okay. Right. Let's move on. Right. Now, again, go back to that classification. Now, in the classification, we had non-mechanical waves, non-mechanical in the sense electromagnetic waves and mechanical waves. Now, we are going to go into mechanical side. Right. Now, we are going to go into mechanical side. Now, we have finished the discussion on features about electromagnetic waves. And now, we are going to go into mechanical waves. Right. So, as a second one, write down mechanical waves. Next heading, mechanical waves. Next heading, mechanical waves. Mechanical waves. Mechanical waves. Right. So I told you, the first classification is based on the requirement of a medium. No? So when it comes to electromagnetic, medium is not mandatory, not compulsory. But for mechanical waves, a medium is compulsory. For mechanical waves, a medium is compulsory. Having a medium is compulsory. So under that, write down. Under that, write down. A medium is. A medium is. A medium is compulsory. A medium is compulsory. A medium is compulsory slash essential. A medium is compulsory slash essential. A medium is compulsory slash essential to propagate to propagate to propagate mechanical waves. To propagate mechanical waves. Okay, now under that, from number 1, transverse waves. Under that, from number 1, transverse waves. Right, look at here. Look at here. Now, if this is the direction of propagation of the wave, in transverse waves, their vibrations are like this. Vibrations are perpendicular to the direction of propagation. Right? So they are like this. Right? So this is the direction of propagation. This is the direction of propagation. Right? And look at the board. Look at the board. Now, when they vibrate in the perpendicular direction, their vibrations are always perpendicular to the direction of propagation. So when they vibrate in the perpendicular direction, there are maximum and minimum points. Maximum and minimum points. Maximum points are called crests. Right? These points are called crests. Crests. And these minimum points are called troughs. Troughs. Right? And maximum displacement from the center is called amplitude. That you already know from simple harmonic motion oscillations. Now this is the center. Now from this center, maximum displacement is called the amplitude. So therefore, this is amplitude. This is the amplitude. And one last thing. Shortest distance between any two points at same phase. Same phase. What was a phase? What was phase of a wave? We had the same thing in simple harmonic motion. What is phase of a simple harmonic motion? Same idea. Tell me, what is phase of a simple harmonic motion? Quickly, anyone? Phase. PHESC phase, right? Moon phase, නෙමෙයි. ඒක ඉතින් මට ඕල්ලෙන් අහන්න ඕනේ. What is phase of a wave of a simple harmonic motion? Tell me. On, we explain about the phase of a simple harmonic motion. No one. No one. Phase of a wave is the subtended angle at center, right? So we had phase in the respective circular motion of a simple harmonic motion. Phase and phase angle, initial phase angle, we had different things. So phase angle is always in subtended angle at center. Subtended angle at center. So this is also same. Now for this wave also, there's a respective circular motion. So there's a subtended angle. Subtended angle at center is called the phase. Right? Now, what I was going to explain is about lambda. Lambda is the shortest distance between any two points at same phase. Any two points at same phase. So which means now if there is at 0, 0 and 0 it should be. If that's a point at 90, 90 and 90, 180 and 180 and 180 likewise. Right? Any two points at the same phase. So lambda is measured from here to here. Lambda. From this point to this point. Lambda. Right? Wavelength. Take this down. Copy this down. Copy this down. and mark all these things. We have mark all the things. Okay, done. See, now the movement of particles here is up and down, upwards and downwards, but the direction of propagation of the wave is to the rightwards, right? So therefore, that is perpendicular. That is perpendicular. If you have a perpendicular movement of particles in a wave, such waves are called transverse waves, right? If you have a parallel movement of particles when the wave propagates, such waves are called longitudinal. That is what we are going to discuss next, right? So below this first point, after this diagram, write down first point, right? After the diagram, first point, motion slash movement. Motion, first point, motion slash movement. Motion slash movement of particles. Motion slash movement of particles is perpendicular to is perpendicular is perpendicular is perpendicular to direction of propagation is perpendicular to direction of propagation is perpendicular to direction of propagation, right? Highlight perpendicular, highlight perpendicular, highlight or underline, highlight or underline perpendicular, right? Next point, transverse waves propagate as, next point, transverse waves propagate as, I told you these two, crest and troughs, crest and troughs. Second point, transverse waves propagate as crests and troughs. Transverse waves propagate as crests and troughs. Transverse waves propagate as crests and troughs. Highlight crests and troughs. Highlight crests and troughs. Okay, next one, next point. Listen, now about the speed, now if I compare the speed with electromagnetic waves, now electromagnetic waves travel with the velocity of light, no? Compared to the speeds of electromagnetic waves, transverse waves are less in speed, in the sense, now electromagnetic waves are the highest speed And when it comes to mechanical transverse waves, mechanical transverse waves, they are very less in speed. Very less compared to 3 times 10 to the power 8. Next one. Speed of mechanical transverse waves. Speed of mechanical transverse waves. Speed of mechanical transverse waves is very less than speed of light. Is very less than speed of light. Right. Next point. So when it comes to transverse waves also, all 5 wave phenomena can be done. All five. Reflection, refraction, diffraction, interference, polarization, all 5 can be done. Right. Next point. All wave phenomena such as mention all phenomena again one by one. We have mentioned before as well. Mention again, such as, put a comma and mention one by one. Reflection, refraction, diffraction, interference, polarization. Mention again. Reflection, refraction, diffraction, interference, polarization. Now you should be able to remember, right? Now for the fourth, fifth, sixth time, I'm saying these names out, right? Can be done. Check it for one last time. All wave phenomena such as reflection, refraction, diffraction, interference, polarization can be done. Right? Okay. Mention few examples. Mention few examples for mechanical transverse waves. Mention few examples for mechanical transverse waves. Any idea? Any idea? Any idea about mechanical transverse waves? Examples. I'm asking examples. Examples whether they are sound waves, optics, optical waves, done the examples. Any examples for mechanical transverse waves? Anyone? Sound? No. Sound is longitudinal. All sound waves are longitudinal. Right? So mention few examples. First one. Water waves at surface. 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 Second one, vibrations on strings. Second one, vibrations on strings slash wires. Vibrations on strings slash wires. Vibrations on strings slash wires. Within brackets, guitar. Guitars, violins, they have transverse waves. Guitars, violins. Next one, secondary waves. What waves? Yeah, good. I didn't see that in chat. Yeah, good. Secondary waves, within brackets, S waves, like this. S waves. Secondary waves, within brackets, S waves of seismic waves. Seismic. Secondary waves within brackets S waves of seismic waves. Of seismic waves. Secondary waves, S waves of seismic waves. Right. Okay. Now that's the end. That's it for the features of transverse waves. Right. Any questions? Any questions? Again, quickly. Any questions, students? Do you also need an animation for that? What do you say? Need an animation or not? Quickly. Yeah. See? Can you see? Can you see? So this is how a transverse wave is propagated. This is how a transverse wave is propagated. Check the direction of motion of a particle, right? A particle is always going up and down. Particle goes up and down. ඔය රෙඩ් එකෙන් දීලා තියෙන පාටිකල් එක දිහා විතරක් බලාගෙන ඉන්න. ඔය රෙඩ් එකෙන් පාටිකල් එකක් මාක් කරලා තියෙන. රෙඩ් පාටිකල් එක දිහා විතරක් බලන්න. Now if you just check the motion of that red particle, it goes up and down, always up and down. That is this motion. හරි? එක පාටිකල් එකක් යන්නේ up and down විතරයි. It's a back and forth motion. Right? It's clear, eh? Let's move on. Okay, let's move on. Next. Next heading, longitudinal waves. Next heading, longitudinal waves. Longitudinal waves. Longitudinal waves. Put that in longitudinal waves. Okay, look at the board now. Look at the board. Stop your work and look at the board. Stop all your work and look at the board. See? Now, when a longitudinal wave is transferred, it's propagated, it propagates as compressions and rarefactions, which means there are some points, some areas in the space that they get compressed, and there are some areas of the wave in their space they are released. Release in the sense they are not compressed, extends. Such points are called rearractions. See, these kind of points are called compressions. See, look at the board, don't write. These are compressions. And these ones are called rearractions. Rearractions. Right? And if I mark the direction of propagation, that is also same as before, like this. Direction of propagation. Direction of propagation. Now, when the wave is propagated, right? So it propagates as compressions and rearractions, compressions and rearractions, compressions, rearractions. So likewise, the wave propagates, the energy is carried, right? Now, lambda is marked between 2 points at the same phase, no? That is between 2 points at the same phase. Now, same phase is from somewhere here to, if I start from the midpoint of this compression, it should be up to the midpoint of the next compression, lambda, like this, like this. Take it down. Let me mark the motion directions as well. These motions are like this. Motions are like this because compressions, rearractions, compressions, rearractions, compressions, rearractions. So likewise it goes. Take it down. Ask your questions if you have anything. Yeah, any questions? So do we have break? No, usually no. Usually no. Are you asking to pray or something? Is it? Are you asking to pray or something? If you are asking for a break to pray and come, for that I'll give you 5 minutes to go pray and come. Right? Is that? Pray කරන්නද break එකක් ඇහුවේ නැත්නම් නිකන්ද? Take it down. Finish? No. Yeah, usually I don't give breaks in 3-hour classes. Right? For tomorrow you will get a break because that is a 6-hour session, no? That's a 6-hour session. For tomorrow, you will get a break. For 3-hour classes, I usually don't give. And if you want to like pray and come, for that I'll allow you. But otherwise, I don't give a break as an official break. I don't give. There's no dedicated break here. Official in the sense there's no dedicated break. Okay, finished. First point. First point. Movement of particles. First point below this. First point. Movement of particles. Movement of particles. Movement of particles is parallel to movement of particles is parallel to movement of particles is parallel to direction of propagation. Movement of particles is parallel to direction of propagation. Underline, no highlight, parallel. Underline, no highlight, parallel. Underline, no highlight, parallel. Underline, no highlight, parallel. Next one, next point. Longitudinal waves, longitudinal waves, longitudinal waves propagate as longitudinal waves propagate as longitudinal waves propagate as compressions and rarefactions. Longitudinal waves propagate as compressions and rarefactions. Longitudinal waves propagate as compressions and rarefactions. Compressions and rarefactions. Underline, no highlight, compressions, rarefactions. Underline, no highlight, compressions and rarefactions. Next one, next point. Speed of propagation is very less than 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 speed of light. Speed of propagation is very less than speed of light. Right. So here there is a difference about wave phenomena. Here there is a small difference about wave phenomena. Difference is this: when it comes to longitudinal waves cannot be polarized. Listen carefully. Listen carefully. Longitudinal waves cannot be polarized. Cannot be polarized means all other four wave phenomena can be done. Right? All four other wave phenomena can be done. It cannot be polarized only. Cannot be polarized. Right? So we will see why it cannot be polarized when it comes to polarization. Now we are going to discuss about these wave phenomena one by one. Right? So therefore, you will see it along the journey. Why it cannot be polarized? Right? For now, just know that all longitudinal waves or any longitudinal wave cannot be polarized. Any longitudinal wave cannot be polarized. Right? Next point. Next point. Next point. Wave phenomena such as wave phenomena such as wave phenomena such as wave phenomena such as reflection, refraction, diffraction, interference. Reflection, refraction, diffraction, interference can be done. හතරයි පුළුවන්. First 4 විතරයි පුළුවන්. First 4 ഇതറായി පුළුවන්. Right? Wave phenomena such as reflection, refraction, diffraction, interference can be done. For the same point, write down, for the same point cannot be polarized. For the same point cannot be polarized. For the same point cannot be polarized. Cannot be polarized. Cannot be polarized. Okay, now let's mention few examples. Okay, any examples for longitudinal waves? Any known examples for longitudinal waves? Yeah, let's see. What do you say, online students? Sound, optics. Sound is correct. Optics කියන්නේ longitudinal නෙමෙයි. Why? Optics is an electromagnetic wave. Optics means visible light. No, optics means light. Light, visible light, all of them are electromagnetic. Optics and sound is correct. What else? Sound. Everybody is saying sound. Everybody is saying sound. Okay. Okay. Yeah, sound is correct. Sound is correct. First one, sound waves. First one, sound waves. First one, sound waves. Sound waves. Any type of sound wave is longitudinal. Sound waves. Next one, vibrations in air media. 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 Vibrations in air media means now, as examples, if I give you examples from musical instruments, like flutes. You know flute, right? Flute, trumpet, saxophone. What the end? පිමින්න පුළුවන් කියලා කියන්නේ. And air medium means vibrating inside. Right? What else? Flute, trumpet. Mention few examples within brackets. Flutes, trumpets. Next one. Waves generated in slinky. You know slinky, right? Waves generated in slinky. Waves generated in slinky for parallel vibrations. Waves generated in slinky for parallel vibrations. Waves generated in slinky for parallel vibrations. For parallel vibrations. Okay. So that is all about the longitudinal waves. Now again, I'll show you a longitudinal wave before moving on. Okay. Look at here. Give me a minute. Okay. Can you see? That is how compressions and reactions work. That is how compressions and reactions work. Any questions? Can anyone send me the answers? We have not. Yeah, please. So if you have something like that, so always feel free to ask it among your friends in the chat or in the group also. I don't mind. Right? Because this is something you all should do as a group. Right? This is not a game to win individually. Right? This is something to win as a group. Right? As a group. That's good. Right? Is it clear? Is it clear about fractions and compressions? So this is how the longitudinal wave goes. You can see the direction of wave, right? Direction of propagation of wave is to the right, rightwards. And particles are moving as fractions and compressions. Just focus on one red arrow here, then you will understand better. Focus on one red arrow here. It's a compression and a reaction. Compression, reaction changes. Can you see? Compression, reaction changes. So likewise, the energy is carried. Okay. Right. Any questions up to this point? Now we have finished the discussion about electromagnetic waves, then mechanical waves, mechanical transverse waves, mechanical longitudinal waves. Any questions up to this point? Or if there are no questions, tell me it's clear, then we can move on. And if you need anything to clarify, you can ask now. Any questions? Clear. All right, so let's move on. Next heading, wave fronts. Wave fronts. Wave fronts. Wave fronts. Right. Look at the board. Okay, now again stop all your work and look at here. Look at the board. Now, see, this is a wave. This is a wave which propagate in this medium. See, this is a wave which propagate in this medium, right? And this is another wave. Let's say these are three parallel waves which propagate in the medium, right? Three parallel waves which propagate in the medium, right? Right. Let me draw one last crest. Right. Look at the board. Okay, the idea is like this. The idea is like this. Now we know when a wave propagates, it has crest and troughs, no? Crest and troughs. Now, when we demonstrate in the sense when we draw a wave, right? If we need to graphically represent a wave, present, na? Present is a very good point, and based on wave fronts, most of the things coming up are relied on, right? Are relied, right? So therefore, listen carefully, listen very carefully, right? Now, when it comes to a wave, it propagates as crest and troughs. It propagates as crest and troughs. Now, when we draw waves, now if we draw the entire wave, that is not that convenient. No? That is not that convenient. So therefore, as a solution, and as a clear method to draw waves. Otherwise, we can draw any type of wave using crest or troughs, or sometimes rearfractions and compressions. So likewise, any type of a wave can be drawn as we wish, but there should be a standard. There should be a standard when we are dealing with waves. So therefore, as a standard, these wave fronts are introduced. Wave fronts are introduced. In wave front, what is done is, don't take this down. Now, I didn't ask you to take down, right? I didn't ask you to take down. Don't take down. Wave fronts means we are drawing only the lines which connect the crest of the wave. The lines which connect crests of the wave are drawn as wave fronts. Now, as an example, here we have three crests. No? Three crests. So these three lines connect these crests. So if I convert this to the wave front diagram will be like this. See, if I convert this to wave front, the wave front diagram is like this. Wave front diagram is like this. And always direction of propagation is perpendicular to direction of wave fronts. Now wave fronts are like this. Always direction of propagation is perpendicular. Like this. Direction of propagation is perpendicular to wave front. Direction of propagation. Direction of propagation is always perpendicular to the wave front. And we know from the previous parts of waves, distance between, shortest distance between any two points at same phase is called lambda, wavelength. Now, these 2 points are also at the same phase. Crest to crest, no? Crest to crest. So that is also at the same phase. So therefore, this distance here is lambda. This is lambda. So similarly, the distance between these two wave fronts is also lambda. This is also lambda. Right? So that is the standard. So therefore, here onwards, when we need to draw something about waves, we don't draw the wave. The physical wave we don't draw, the appearance we don't draw. We have to stick to wave fronts. Right? So clearly we can see bendings or straight propagations, bent propagations, everything using wave fronts. Right? So clearly we will see. So that's why wave fronts are used. Right? So tell me whether that idea is clear before going on to the note. Before going to the note, tell me, is that idea clear? Is that idea clear, students? So, sir, only in wave fronts the direction of propagation is perpendicular. Direction of propagation is perpendicular to wave fronts. To wave front. Now, this is the wave front now. So for this wave front, direction of propagation is perpendicular. Right? Like this. Any other questions? Any other questions? What else? Clear. If possible, put your answers, put your questions, doubts to the main chat of Zoom, if possible, because the reason is with this new update, I told you this several times, with this new update, when you drop a direct message, I have to go into that particular chat box that is created under your name, and then only I can check your chat here. right? So when you drop a direct message, it goes to a separate chat box under your name, right? Then I have to go to the laptop and check them one by one. Otherwise, if you are putting it to the main chat, that is visible at once. Then I can see it at a distance as well, at a distance like this distance, right? So therefore, if possible, do that if possible, right? Okay, write down first point under wave fronts. Don't draw anything. Don't take down anything. First point, write down lines which connect. Write down lines which connect. Crests of lines which connect. Crests of lines which connect. Crests of each wave. Crests of each wave. Crests of each wave are called wave fronts. Crests of each wave are called wave fronts. Crests of each wave are called wave fronts. Then for transverse also the direction of propagation is perpendicular to the wave. No. This is not about the direction of motion of particles. Right? Now you have messed it up with the direction of motion of particles. This is not about the direction of motion of particles. Wave fronts are the lines which connect crests. That's a line. That's a graphical representation, a graphical representation, right? So those are the lines which connect crest, right? That's a wave front. That's a graphic. That's a graphical representation. Direction of propagation is perpendicular to the wave front, right? The wave front and direction is perpendicular, right? Otherwise, I haven't drawn the wave here. Right? Wave vegamang calling under transverse waves and longitudinal waves. This is not the wave. This is just the wave front. Right? Okay, take this down now. Take it down. If you are using different colors, you can use different colors and take it down clearly. Right? So take it down as it is clear to you when you refer it again. Yeah. Meanwhile, ask any other questions if you have. Wave front is only a graphical representation. No? So there's no movement of particles in wave fronts. No. Real wave real wave instead of drawing the real wave is like this. Real wave. Instead of drawing this real wave, we are drawing wave fronts as a standard graphical representation. That's the idea. Make a wave fronts. Real wave. Wave front. Wave front is a graphical representation. This diagram is complex. Right? So therefore, this is the standard when drawing waves. When drawing in the sense, when we represent a wave graphically. This is the standard, right? It is like this. Now, you know, look at the board, it is like this. So in reality, a resistor is like this. In reality, a resistor is like this. In reality, a resistor is like this. Now, without drawing the resistor, we draw the circuit symbol of a resistor like this in circuits. We draw the circuit symbol. Something like that. Instead, we will be drawing this standard wavefront. Something like that. Resistor එක තමයි මේක වෙන විදියකට ඇඳලා තියෙන්නේ. වෙන විදියකට ඇඳලා තියෙන්නේ, which means now since we need to avoid drawing the wave entire wave, to avoid drawing the entire wave and to make it standard, wavefronts are introduced. Is it clear now? Yeah, that's good that you asked that question out. Right? Wavefront is just a graphical representation. Right? Just to replace this real wave. Real wave එක අපි හැම වෙලේම ඇඳගෙන ඉන්න ගියාම මේක කරදරයක්නේ. Right? මේ විදියට හැම වෙලේම ඇඳගෙන ඉන්න ගියාම වරද ඊට වඩා ලේසිනේ මේව අඳින එක. It's easy and clear. That's the thing. මෙතන අතරම wave එක තියෙනවා. Okay, have you finished copying down? Okay, finish copying down, students. Shall we go to the note? Take down these diagrams in a clear manner, which should be clear enough for you when you go through these things again and again. What about the ones on YouTube? What about the ones on YouTube? Are you also on the track? What about you? Okay, first point. Direction of propagation. First point. Direction of propagation. Direction of propagation of wave. Direction of propagation of wave is always direction of propagation of wave is always perpendicular with wave fronts. Is always perpendicular with wave fronts. Is always perpendicular with wave fronts. Next point. Distance between two consecutive wave fronts. Distance between two consecutive wave fronts. Distance between two consecutive wave fronts. Distance between two consecutive wave fronts is equivalent to wavelength within brackets lambda is equal to wavelength within brackets lambda. Right. Next heading. Next heading. Types of wavefronts. Types. Next heading. Types of wavefronts. Types of wavefronts. Under that first one, plane wavefronts. Under that first one, plane wavefronts. First one, plane wavefronts. Under that first one, plane wavefronts. Plane wavefronts. Okay, first write down, then I'll explain. First write down. Plane wavefronts are due to plane surfaces. Plane wavefronts are due to plane surfaces. Plane wavefronts are due to plane surfaces. Right. Listen. Plane surfaces in the sense, now as an example, let's say we are trying to push a basket of water with a plain disc or something, with a disc. We are trying to push basket of water with a disc. Putting a disc inside, we are trying to push that. So once we are trying to push it, so we will see some kind of water waves like this, no? Some kind of water waves like this. Right? Now, in those all water waves, they are simultaneous. So crests are inline. All crests are inline. So therefore, you will see plane wave fronts. Right? I'll show you a graphic as well. So in such cases, we will see plane wave fronts. Take it down. Take this down. Take down the diagram. Okay, can you see? Now imagine the crest of the waves here. Imagine the crest of the waves here, right? Imagine the crests. Now if you imagine these crests and if you connect all these crests three-dimensionally, right, you will see something like this if you get a top view, right? So there is one occasion, there is an occasion, right? Next. So that one line you have drawn is one wavefront. Yeah. One line means one wavefront. 1, 2, 3, 4, 5. Here we have 5 wavefronts. Bucket of water instance කියලා කියන්නේ ඒක basket of water, right? Basket එකක් කියන්නේ මොනවද? Pool එකක් කියන්නේ swimming pool එකක් කියනවා, right? Assume we have a swimming pool, right? Swimming pool එකක් තියෙනවා. Swimming pool එකට අපි plane මොනවා හරි object එකක් plane objects කියලා කියන්නේ say you have a wooden block like this. You have a wooden block like this. You have a wooden block like this. And we put that wooden block into the pool like this. We put that wooden block into the pool like this. And if you push water, now due to this pushing, there is a ripple creates. මෙහෙම ripple එකක් හැදෙනවනේ. There's a ripple creates. Right? අර මං කලින් පෙන්නුවා වගේ ripple එකක් එන්නේ. මෙහෙම ripple එකක් එනවා. අන්නේ ripples ඔක්කොම plane. They are plane wavefronts. අයි මේ ripples ඔක්කොම ටික මෙහෙම මෙහෙම යන්නේ. ඒතර wavefronts යන්නේ මෙහෙම මෙහෙම. Can you imagine? මෙහෙම ගලා අපි push කරොත් මෙහෙම push කරනවා. ඒතර මෙහෙම ripples යනවා. Is it clear? Aida. So later you can try it at home, right? After the class, you can try it out and see how plane wavefronts and the next part coming up is circular wavefronts. You can see how plane wavefronts and circular wavefronts create. Yeah, we have to push. Yeah. Dharma push kara. Okay. Number 2, circular wavefronts. Number 2, circular wavefronts. Circular wavefronts. Circular wavefronts. Okay, listen first. So when it comes to circular wavefronts, listen now. Circular wavefronts are due to point objects. Point objects in the sense. Now again, if I get the same example of the pool, right? Now for the pool, if we put a finger like this, now finger is a point object. If you put a finger, have you seen around the finger, have you seen this kind of a ripple goes in all 360 directions? In all 360 directions, ripples go like this. Let me draw it. Now if you put a point object like this, now around that point, ripples are going on like this. Ripples are going like this. Like this. Right? So which means waves are all around. Infinite number of waves are here. මෙතනත් ආර wave එක ඕන නම් wave එක මෙහෙමයි තියෙන්නේ. Here the wave is like this. the wave is like this. And here, there are multiple waves like this. There are multiple waves like this. And lines which connect the crests are wave fronts. Lines which connect crests are wave fronts. ඇත්තටම wave එක තියෙන මෙහෙම. Right? Wave එක අඳින්න ඕනේ නැහැ. I just have drawn for you to see it properly. Right? Since you asked few questions about wave fronts. Right? This is how the wave is. Now, when these waves are propagating all around, wave fronts will be, now if you connect all crests, it will be a circle. Because waves are propagating at the point object at the same time. And then it spreads out. So if you connect all wave fronts, it will be exact circle. That is the exact circle. So in such cases, we can see circular wave fronts. In such a case, you can see circular wave fronts. Right? Is it clear? First tell me before taking down, is it clear? This is the point object. This is the point object. And now distance between any two of those is lambda. Distance between any two of those is lambda. Right? And direction of propagation is like this, all around. Direction of propagation is all around. Right. First write down. First point under circular wave fronts. First point under circular wave fronts. Write down. Circular wave fronts are due to. 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 Circular wave fronts are due to point objects. 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 Okay, now take this down. This diagram, second diagram. Take this down. Only the second diagram. So is it okay if I highlight the terms? Yeah, that's fine. That's fine. That's fine. That's up to you. Now, that is your note, not mine. Right? If I didn't say you to highlight, but if you feel like you should highlight a certain word, that is totally fine. That is your note. You are the one who is going to use it until your exams. Right? highlight කරලා හරි නැත්තම් බිත්තිය කෙල්ල ගත්තත් කවන්න නැහැ කොහොම හරි මතක තියෙන්නයි ඕනේ. හරි. මතක තියෙන්නයි ඕනේ. Okay, finished? See, I'll show you some circular wavefronts as well. Okay, look at here. Look at here. Now this is a assume this as a water tank. This is a water tank. This is a water tank, right? And here we have a water supply, right? Now I'm going to turn this on. මේ water supply එක turn on කරනවා. මේ supply එක on කරපු ගමන් water comes out. When water comes out as water drops. Drops තමයි මේකෙන් එන්නේ. Okay? Water drop is also a point object. හරිනේ? Water drop is a point object. Since water drop is a point object, it creates circular wave fronts. ඔය වැස්ස වෙලාවට එහෙම දැකලා නැද්ද? ලස්සනට පේනවා. එතකොට නම් ඉන්ටර්ෆියරන්ස් එකක්මයි වෙන්නේ මේ. ඉන්ටර්ෆියරන්ස් අපි ඉස්සරහට කතා කරනවා next week. Right? දැකලා තියෙනවනේ. Now if you are looking at a still a lake or something, tank or lake or whatever it is, when rain drops, right, you can see circular wave fronts. පොඩි කාලේ කරන්නේ. See? See, when these water drops, can you see how these circular wave fronts form? Can you see the circular wave fronts? So those are the circular wave fronts. Right? Is it clear? So due to point objects, the thing you need to take out is this. Due to point objects, you will create circular wave fronts. Due to plane surfaces, plane objects, you can create plane wave fronts. Right? There are only two types of wave fronts, circular and plane. Any other questions? Clear? Good. Very good. Okay. Right. Okay. Any other questions? All right. Good. Okay. Very good. Listen. To demonstrate all these wave phenomena, there is something called ripple tank in labs. Ripple tank. There is something called ripple tank. Ripple tank. මේ school lab එකේ තියෙන එක. In school lab, we have something called ripple tank. Using the ripple tank, it has a mechanism to demonstrate all of them, like plane wave fronts, circular wave fronts, reflection, refraction, diffraction, interference, except polarization, all other wave phenomena, plus about these wave fronts, it can be very clearly observed using ripple tank. Right? Ripple tank කියලා එකක් තියෙනවා. ripple tank එකෙන් ඔය ඔක්කොම බලන්න පුළුවන්. Right? මම ripple tank එකේ වීඩියෝ එකක් group එකේ share කරන්නම්. ඒතොර ඒකත් බලන්න. දැන් වීඩියෝ එක පෙන්නන්න නැතුව ripple tank එකේ experiment එකේ වීඩියෝ එකක් group එකට දාන්නම්. Right? So I'll put a video of the ripple tank into the group so you can go there and watch it later. Right? To get an idea. ලස්සනට පේනවා ඒකේ. Okay. Next point, as a next point, write down. Next point, write down. All types of wave fronts. All types of wave fronts. All types of wave fronts can easily be demonstrated. All types of wave fronts. All types of wave fronts can easily be demonstrated. Using ripple tank. using ripple tank. Can easily be demonstrated using ripple tank. Can easily be demonstrated using ripple tank. Right. So in the ripple tank, there's a nice setup with water, and with a projected lamp. From that lamp, we can clearly see how wavefronts are forming, and there's a screen in the sense a white sheet screen in the white sheet that works as a screen, that acts as a screen. So on the screen we can see all these wave fronts plus wave phenomena, right? Both are possible, wave fronts and wave phenomena, right? Any other questions up to this point? Quickly, any other questions up to this point, students? Any other questions up to this point? No. Okay, all good. As the next heading, write down phenomena of waves. Next heading, phenomena of waves. Phenomena of waves. Phenomena of waves. Phenomena of waves. Now again mention all 5 wave phenomena one by one. Again mention all 5. Now you know, because I have explained it several times. Write down all 5 wave phenomena. Write it down. Reflection, then refraction, then diffraction, interference, polarization, and polarization. Okay, again take down the heading as reflection of waves. Take down the heading as reflection of waves. Heading 1, reflection of waves. Reflection of waves. Reflection of waves. Okay. Under reflection of waves, write down deviation of path. Write down deviation of path. Deviation of path. Deviation of path of a wave due to an obstacle. Deviation of path of a wave due to an obstacle. Deviation of path of a wave due to an obstacle is reflection. Is called reflection. Is called reflection. Is called reflection. Okay, listen. Right. Now the next parts coming up are now we have just started the discussion on reflection, and this lesson is all about wave phenomena, which means we will be discussing about all these 5 wave phenomena one by one, right? In some wave phenomena, we have to draw wave fronts. In some, calculations. In some, both, right? So likewise, that part goes, right? So we have just started reflection, and the next day plan is we will be covering reflection, refraction, and diffraction by next day, right? Reflection, refraction, and diffraction by next day. And in some parts, as I told you, we have to draw wave fronts. So therefore, you have to have a firm knowledge, a solid knowledge on wave fronts, right? So we'll see how wave fronts act when it comes to those areas. And since this is the first day, starting day, all the fundamental knowledge required for the coming up parts of the lesson are discussed now, right? Now we have discussed all the fundamentals. So which means those fundamentals are going to be very much useful and connected to all the parts coming up in next 3 days, right? So therefore now the foundation is done. This is the foundation. This is the foundation. Now the foundation of waves is done, right? Now next week onwards we will build all walls. The foundation විතරයි දැම්මේ. Walls ගහලා roof එකක් දාලා ඉවර ගන්න ඕනේ. Foundation එක කියලා කියන්නේ that is what you need to have to proceed here onwards. That's the foundation, right? To start building walls, you have to have a foundation. Now the foundation is done, right? So in the next part, as I told you, we will be discussing about all 5 phenomena one by one in depth, in a comprehensive manner, right? Okay. And about tomorrow, so as planned, we'll be starting the seminar at 8:30, and I hope all of you will be there on time. I'll be starting sharp at 8:30, right? I'll be starting sharp at 8:30. So please be there at 8:30. And as I told you, I'll be giving a break around 12:30. And again, you can come back, right? So there's nothing to bring. You can just come to the class as you are coming to any class, any other class, or in a regular day. And the tute and other things, other materials needed will be provided, right? No meals are provided. No meals are provided. Right? Okay. Right. So I hope all of you will be there at 8:30, right? And please be there at 8:30 and cover it up. Since we have finished mechanics last month, now once the practical seminar is also finished, which means all the parts of mechanics, even without missing a single part, without missing a single word, mechanics are covered, right? So likewise, after waves and oscillations are finished, I'll take another separate day to cover practical sessions on waves and oscillations, right? So likewise, we'll do 4 or 5 practical sessions before your exam, and that's how we are going to cover all practicals, right? So other than that, after targeting, finally targeting exam also, I'll conduct another separate practical seminar with the targeted questions, and these are the regular practical seminar sessions ongoing with the ongoing lesson, right? Okay. Any other questions? Next day will it be free? Next day means you're asking about tomorrow. Are you asking about tomorrow? Yes. No, it's the second week. No. That will be a paid class. Yeah, and about the website thing that you asked. Yeah. Now, since final updates are ongoing, once it is done, once it's totally completed, I'll drop a message, I'll circulate a message to your group that it's live, and then you can go there and complete the enrollment, right? The ones who have paid the fee already to Machma Institute, what you can do is they have provided you a separate invoice that your payment has received. So you can upload that invoice issued by Machma, not your payment invoice, right? If you have paid the payment to the institute, this is only relevant for the students who paid the payment to the institute. So you can upload that invoice that is issued by the institute there when you are enrolling, and if you have paid it as a direct payment, you can upload that your direct payment slip there and complete the enrollment. All right, any other questions? Any other questions about today's things or seminar tomorrow? Any other questions? Your participation for tomorrow's seminar is compulsory. Now, if I notice a lack of participation for the live class, I'll think of the other coming up seminars. Now, this is the first seminar we are going to have now, right? So, if I feel like your participation is not sufficient for the live session, I'll think of the other seminar sessions coming up, right? I mean, I'll think twice or thrice before other seminar sessions coming up, right? So therefore, I need you to be there in the live class, right? All right then. Okay. So since there's no any other questions, I'll end the session here. See you all in the next class, and see you all tomorrow before the next class, not next class. See you all tomorrow, right? And you can share the message, circulate the message among your friends and colleagues. If there's anyone who need to join, because it will be a free session, so anyone can join and get it done, right? Anyone can join and get it done. The only thing you need is the dedication and the effort, right? So if you can put that dedication, put that effort there, you can get it done, right? I'm delivering it free, right? Then anyone can join and take the advantage, get the advantage, right? So if there's any friends, you can share the message and ask them to join, right? So repeating again, if you are around Colombo, you can come physically, and if you are a remote student, you can join via Zoom or YouTube, right? Anything is fine. Okay, any other questions? All right. So since there's no any other questions, I'll wind up the session here. Okay then, see you all in the next class. Go safe and stay safe. Study hard, right? Good night and goodbye.